All right, our next conic section is a circle. Circles you've worked with before. We've done equations of circles and integrated. So we're going to graph them and write them today, but it should be something that you're like, okay, I kind of remember doing this before. Okay, so where circle comes from, here's my double-naped cone. If you take a horizontal cross section that's perpendicular to the base anywhere, then you're going to get a circle. Or so not perpendicular, parallel to the base. Okay, so a circle is a set of all points x and y that are equidistant from a fixed point called the center of the circle. So here's the center, which we use HK for the center. And then a point on the circle, any point on the circle is called XY. Okay? This fixed distance right here is your radius, which is we use R. Okay? So if I asked you to find the length of R, you could use the distance formula, right? And then that would give me the set of all points on the circle. So let's use the distance formula using what we have here. The distance formula, D equals square root of x2 minus x1, so your first x value minus your second, or your second x value minus your first, squared, plus y2 minus y1. So what I can do is I can call this x1, y1. And this is my x2, y2, and then use my distance formula. So instead of doing d equals, we labeled it r. So r equals square root of x2, which is just x, and then minus x1, which is h squared, plus y minus k squared. Now, if I said, okay, I want you to get rid of that square root, I don't want the square root in it, you could say, all right, you can square this side, but then you would have to square this side. This square would cancel out the square root, and you would just have x minus h squared plus y minus k squared equals r squared. And that is the formula for a circle. Okay, now it should look very similar to an ellipse to you, because the x minus h squared plus the y minus k squared, but you might be saying, where's the denominators? Well, the denominators are the exact same number on a circle. So they're 4 and 4, but then we don't write them that way. We get rid of them and we have it equal to a value of r squared instead of it equal to 1. Okay, so I'll explain that better. If you're like, what? I'll explain that better when we get to number 2. Okay. Graph the equation, also state the radius in the center. So this is actually super easy. We do this in integrated. No one there has a problem with it. HK is your center. -1, 3. And then r squared is 25. Please realize that. So r is 5. So your radius is 5. You don't have to write this down every single time. I just don't want you to think it's 25. Okay, now you're ready to graph your circle. So you're going to graph -1, 3 as your center. Then for your radius, realize it's horizontally a distance, or it's like having an a value of 5 and a b value of 5. So you're going to do your horizontal distance from the center as 5 and your vertical distance from the center as 5. In other words, you're going to go right 5, you're going to go left 5, and then you're also going to go up 5 and down 5. Then you can go ahead and connect your 4 points to form your circle. Here we go. And there's my circle. Okay, so here's how I'll explain the difference, or why this is not an ellipse versus why it is a circle. So if you thought this was an ellipse, I'll tell you why it's not an ellipse. Well, first off, it has an x squared and it has a y squared, and there's addition separating it. So it's either an ellipse or a circle. The reason why I know it's not an ellipse is because these coefficients on x squared and y squared are the same. Okay, so if I thought it was an ellipse and I was like, I need to get it equal to 1, and I divided by 18, you would get x squared over 9 plus y squared over 9 equals 1. And if I said, did you that first step to you, is it vertical or horizontal? You have a squared and b squared are the exact same thing. So the fact is that this is not an ellipse. This is a circle. So if you look at the equation of a circle, it has a lead coefficient of 1, right? There's a 1 here and a 1 here. It has coefficients on x and y of 1. So what I need to do is I need to get those coefficients to be 1. So to do that, I'm going to divide by 2. Divide everything by 2, and you get x squared plus y squared equals 9. Now you can see the center is 0, 0, and your radius is 3. So 0, 0, and then right 3, left 3, down 3, up 3. And there's my circle. All right, next one. Now, at first glance, you say, okay, it has a y squared, but x squared's on the other side of the equation and it's minus. Well, in order to compare them, they have to be on the same side when there's both of them. So the first thing that we're going to do is we are going to add x squared to both sides. So now you have x squared plus, because we added it, and this is positive right here, y plus 2 quantity squared equals 36. Now it's a nice easy one. So your center, 0, negative 2. Your radius, 6. 0, negative 2, and then down 6, up 6, right 6, left 6. Notice how I don't count like 1, 2, 3, 4, 5, 6. I use the numbers for help. Like if I know that I'm at 0, going right and left 6, I'm at negative 2, I'm going up 6, I'm at 4. If I go down 6, I'm at 8, negative 8. All right, last one. Center, 4, negative 5. R, radius, 1. R squared is 1, square root of 1 is 1. So 4, negative 5 is my center. And then up 1, down 1, right 1, left 1. So a very teeny tiny cute little circle here. There it is. Okay, next part. Write the standard form of equation of a circle given the radius and center. So now I gave you HK and R, right? So we're going to do x minus h squared, which is 0 squared. So instead of writing that, I'm just going to write x squared plus y minus 0 squared, which is just y squared, equals 4 squared, which is 16. Next one, x minus a negative 4, so plus 4 squared, plus y minus 3 squared equals 9 squared, which is 81. Next one, x minus 2 squared plus y minus 3 halves squared equals root 7 squared is 7. Right, not too bad. Actually, super easy. Okay, so now we have writing an equation of a circle still, but if you notice on the 5, 6, 7, I gave you the center and the radius is what you need. I gave you the center and the radius. These, I'm not giving you the center and the radius. I'm giving you the center and another point. There's 2 ways to do these problems. I'm going to show you the fallback way in case you forget the way that I teach you that I do it, but the way that I do it is way easier than the way that the fallback way. We're going to start with number 9 because 8 is too easy. We'll come back up to 8 and do the, once we know our easy way of doing it, we'll do it that way. Okay, write an equation of a circle with center negative 3, 5 and passing through the point. So I want you to realize that I gave you the center, which is HK, but I did not give you R. I gave you a point that's on the circle, XY. Right? So one way of doing this is thinking about, I gave you the center, I gave you a point, you can find the radius using the distance formula. Okay? That's the longer way I personally think of doing it. So you can do R equals, and then you can do square root of x2, which is 4, minus x1, which is a negative 3, square it, plus y2, which is 2, minus y1, which is 5, square it. You have R equals the square root of 7 squared, which is 49, plus negative 3 squared, which is 9. So you have R is equal to the square root of 58. Oops, I put R squared. R equals the square root of 58. And then I need to know what R squared is, which is 58. So then you can write your equation of your circle. You can do x minus h squared plus y minus k squared equals R squared, which is 58. And there's your answer. So that's one way, and you might be saying like, oh, that's easy. It is easy, right? But there's an easier way even, okay? So here's how I do it, which is an easier way. I'm going to erase this because I should have left it to show you got the same answer, but it's fine. I start off by saying I was already given my center. So I'm going to start off by writing x minus a negative 3 squared plus y minus 5 squared equals, and then I wasn't given r squared, but I have 2/3 of my equation, more than that. I have most of my equation here. So I can look at it as 2/3, that's fine. I just need this r squared part right here, right? Okay, so if the other thing you realize that I gave you is x, y. I gave you an x and a y value, an x value and a y value. So what you can do is plug in the x and y value. So I can plug in 4 plus 3 squared, plus, plug in 2 minus 5 squared, and see what that is. That is 49 plus negative 3 squared is 9, which is 58. Okay, so if you look at this work compared to this work, it's the same pretty much. You just wrote more, right? This you had to get the square root and then square it. This one you didn't have to do that. So basically, we just did this right here, right? Smart, huh? Okay, so let's go do 8 using that method. It says write the equation of a circle at the center at the origin, which is 0, 0, and passing through the point 0, negative 3. So I gave you HK, and this is a point XY. So you're going to start by writing the beginning of your circle, x minus h squared plus y minus k squared. Since they're both 0, x squared plus y squared equals. Box it because I'm almost done. And now I just need that r squared value. So I'm going to plug in 0 for x and negative 3 for y. 0 squared plus negative 3 squared. That's 0 plus 9, which is 9. So there's a 9 right there. And that's it. All right, number 10, we're going to do the same thing. Make sure you know which one's the center and which one's the point, because that's the only thing people mix up is they'll just not read. Write an equation of a circle with center, negative 1, so x minus 1 squared plus y minus a negative 2 squared equals. And I like to box it because I'm almost done. All right, so now I'm going to find the r squared by plugging in x and y. That's plugging in a 4 for x and plugging in a 6 for y. So that's 3 squared, which is 9, plus 8 squared, which is 64. 9 plus 64 is 73. Okay, next one. Write the equation of the circle with center, negative 5, 0, passing through 1, negative 1. So I'm going to do x minus a negative 5, so plus 5 squared, plus y minus 0 squared is just y squared equals. And then I just need to plug in x and y. Notice I box so I don't accidentally write down like 1 minus 1, or plug, like I don't write down like all numbers is what I'm trying to say. All right, plug in 1 for x. 1 plus 5 squared. Plug in negative 1 for y. So that's 6 squared, which is 36, plus negative 1 squared, which is 1, so 37. And there's your equation of your circle. Okay. Next we have write an equation of a line that's tangent to the circle, x squared plus y squared equals 25 at 3, 4. Also, I want to add another problem that we're going to add to the next page right here that's similar to example 4. So we're going to do example 4, and we're going to do a part 13 because I want to make sure you'll see why. Okay, write an equation of a line. So that's my first clue here. Write an equation of a line that is tangent to the circle, x squared plus y squared equals 25 at the point 3, 4. So first thing that I want to do is I want to say, okay, an equation of a line is y minus y1 equals m times x minus x1. So to write this equation of the line, I need a point on the line. And I need the slope. Okay, that's what I'm going to need to find. Plug it in. Boom, I'm done. Okay, so next thing I do is I say, all right, I need to draw a picture of what this looks like because what, right? Write an equation of a line that's tangent to the circle. X squared plus y squared equals 25 at the point 3, 4. So I'm going to draw a circle, just a sketch of a circle. I know the center is 0, 0 because it's x squared plus y squared. And then it's tangent at the point 3, 4. So I'm going to graph the point 3, 4, which I'm just is approximating right there. It doesn't have to be that accurate. And I want to write the equation of a line that's tangent at that point. So now let's draw the tangent line, which remember only hits it once. It's right there. And it's not that great, but I'll try it again. Oh, oh, oof, 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 oof. I have a problem. Oh gosh, that's better. Okay, that's good enough. That was a little OCD kicking in. All right, so there's my tangent line. I want to write the equation of that purple line. I'm going to refer to it as the purple line. All right, so to write an equation of that line, I need two things. I need a point on the line. Do I have a point on the line? Yes, 3, 4. One thing done. Now I just need the slope of that line. To find slope, I need 2 points. Do I have 2 points on that line? No. However, I do have 2 points that I can connect to make a line. So this line I can find the slope of. Now, what's so special about this line and the tangent line? This is a radius and a tangent line. A radius and a tangent line are always perpendicular. So what I can do is I can find the slope of that red line first. Slope formula, remember, is y2 minus y1 over x2 minus x1. So 4 minus 0 over 3 minus 0, which is 4/3. So the slope of the red line is 4/3. I don't want the slope of the red line. I want the slope of the purple line, which is perpendicular to it. So the slope that's perpendicular to 4/3 is the opposite, which is negative 3/4. So now I can write my equation of my line. Y minus y1, which is 4, equals m, which is negative 3/4, times x minus x1, which is 3. And there's your equation. Okay, I want to do another one that's not centered at 0, 0 because people get hung up on like, couldn't you just do this and couldn't you just do that? And it's all because of the 0, 0. So I'm going to make up one. And it's going to be write the equation of a line that's tangent to the circle. X minus 2 quantities squared plus y plus 5 quantities squared equals. And then I need to figure out what that is because I'm making it up off the top of my head. And it's going to be at the point, let's do 3, comma, negative 1. All right. So I want to fill in the accurate. That doesn't matter, but I want to fill it in accurate. And so I'm going to plug in 3. That gives me 1. Plug in negative 1. That gives me 6. So this is 17. Okay. So in order for it to be true, this would have to be 17. I just didn't want to put a random number there. Okay. So write an equation of the tangent line to that circle at that point. So I still like to do a sketch. So I'm going to do like a circle over here. I'm going to draw in the center. That's the center of the circle is positive 2, negative 5. And then I want a point tangent, I want the point 3, negative 1 on my circle. 3, negative 1. And then I'm going to draw my tangent line. I'll do it in purple again. So let's call it the purple line. Okay. All right, so I need to write an equation of that purple line. To write an equation of that purple line, I need, first off, a point on the line. I have a point on the line. It's 3, negative 1. I also need the slope of that line, which is going to end up being perpendicular to the slope that I do find. So let's find the slope of this red line right here, which is the radius that's perpendicular to my tangent line. So I'm going to do m equals y2, which I'll call that -1, minus y1, which is a -5, so I'll change it to +5, over x2, which is 3, minus x1, which is 2. So I get 4 over 1, which is 4. So the slope of the red line is 4, but I want the slope of the purple line, which is perpendicular to it, so I need the opposite reciprocal. So then I can write my equation of my line, y minus -1, so plus 1 equals -1/4 times x minus x1. And there's my tangent line. Okay, last but not least, it says classify each circle as a circle, parabola. We're going to do ellipse because we learned that already, or neither. All right, so let's remind ourselves of how we tell the difference. A parabola, if you look at it, it has two variables, x and y, where one of them is squared. So it has an x squared and a y, or a y squared and an x. Both a circle and an ellipse have an x squared and a y squared. They also both have additions separating those two terms. Now the difference is that if you look at the coefficients on that x squared and the y squared, if they're the same coefficient, it's a circle. If they're different coefficients, it's an ellipse. All right, let's go through each one of these. This has a y squared and an x. So this is a parabola. Let's look at this one. It has an x squared and a y squared, but they're not on the same side. So the first thing I want to do is get them on the same side so I can recognize what it is. All right, if you look, there's an x squared and a y squared. There's additions separating them, but they have the same leading coefficient of 1. Or sorry, they have the same coefficient of 1. So this is a circle. If there was a 3 right here, now it's an ellipse. Okay. All right, let's look at the next one here. X squared, y squared, addition separating. Look at the coefficients on x squared, that's 1. On y squared, that's 1. This is a circle. Last one, x squared and y squared are not on the same side, so let's get them on the same side. X squared, y squared, subtraction, separating this. This is automatically neither. All right, well, there were no ellipses. That's why I wasn't in the directions. Never mind. Okay, so that's it for today's notes.